Hey everyone, welcome back to my channel. I'm Neil and today I'm gonna talk about similar triangles, how to spot them, understand the rules behind them, and use them to solve problems like a pro. If you want to boost your geometry skills and feel more confident in exams, you're in the right place. Before we jump in, make sure to subscribe because I'll be covering more about this topic in upcoming videos. And if you found this video helpful, don't forget to give it a thumbs up. Thank you so much. Okay, let's get started. We are going to talk about similar triangles. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. In fact, there are three main conditions to check similarity of two or more triangles. The first one is AA, which is the abbreviation for angle. For example, we have these two triangles, ABC and DEF. If we have B and E in the same size, both of them are right angle, and C is given 60 degrees and D is given 60 degrees. These two triangles are similar. Why? Because B is congruent to E, both are 90 degrees, and C congruent to F. We know that the sum of all interior angles of any triangle is add up to 180. So this one is 30 degrees. So C is congruent to F, which is 30 degrees. These pairs of angles are equal in size, but you can write the third one, which is A equals D is 60 degrees. In fact, the condition is AA angle. So because of that, triangle ABC is similar to, we should write this in order. A is 60, so D is the first one. B is 90, so the next one is E, so DEF. So these two triangles are similar. The next condition is SSS, which is the abbreviation for side, and side. If the three sides of one triangle are proportional to the three sides of another triangle, then they are similar. As an example, we have these two triangles, ABC and DEF, and we have the lengths of all sides. So we can write the corresponding ratio of all these three sides. In fact, when AC is 3 centimeter, the corresponding side is DF, which is 6. In fact, if you multiply 3 by 2, the answer is 6. So this triangle is twice than the first one. And how about this? AB is 5 centimeter, DE is 10, and this is multiplied by 2 as well. And for the third side, BC is 7 centimeter, EF is 14, and this is multiplied by 2 as well. So we can see that their sides are in proportion, and we can write this ratio AC over DF is 3 over 6, and AB over DE is 5 over 10, and BC over EF is 7 over 14. And if you simplify all these fractions, the answer is 1/2. And we can call this a scale factor So scale factor is 1/2 or 2/1 or 2. Why? Because if you multiply all sides of this triangle by 2, you will have the image DEF. Or if you divide all sides by 2, you will have ABC. So you can call this object, and this is an image. So in this case, object is multiplied by 2, so you will have the image. Or if you consider DEF as object, so ABC would be the image, but the scale factor is 1/2. Last but not least, we have condition SAS. The third one, SAS, which is side, angle, and side. In fact, if two sides of one triangle are in the same ratio as two sides of another triangle, and the angle between those two sides is equal, then the triangles are similar. As an example, we have these two triangles, ABC and DEF. So you can see that these two sides, AB and DE, is in the same ratio as BC over EF. 6/12 equals 8/16, which is 1/2. In fact, these pairs of sides are in the same proportional, and the angle B is equal to angle E, which is 90 degrees. So according to condition SAS, triangle ABC is similar to DEF. Okay. In fact, using these three tests, you would be able to find out the similarity of two triangles, and you can prove that. Okay, now jump into solving some questions. The first one is, we are going to prove that triangle ABC is similar to triangle ADE. Okay. The first thing is that we have angle A, which is in triangle ABC and is in triangle ADE as well. In fact, angle A is a common angle. And the second reason is that because we have these two parallel line and we can consider this as a transversal line, we will have these two corresponding angles and they are equal in size. So let me call this B1 and this is D as well. So angle B1 equals angle D, and the reason is that BC is parallel to DE and BD is transversal line. So in fact, these two angles are corresponding angles. Okay, so the condition is angle, and we can prove that triangle ABC is similar to DEF. Perfect. And the next one, and we have this figure and we are going to find the value of x. Okay, let me call this triangle ABC, and this one is CE and D. I believe that these two triangles are similar, but what is the reason? In fact, we have these two angles. Let's call this C1 and C2. C1 equals C2 because this is vertically opposite angles. So they are equal in size. And the next one is B equals E, and both of them are 90 degrees. So according to condition AA, or angle, I prove that triangle ABC similar to triangle DEC. So I'm gonna write the corresponding sides in ratio. So for writing this ratio, I'm gonna use a rule. Okay, we know that angle A is equal to angle D. Okay, this one. So what is the sides opposite A? This is 8. So I'm gonna write 8. And how about D? Because D is equal to A. So the side opposite D is CE, which is X centimeter. Okay, equals to, and we have angle B, which is congruent to E, but we don't know the lengths of AC or the lengths of DC, so we go for the third one. Angle C here, the opposite side is 5 centimeter, and how about this one is 12 centimeter, so 5 over 12. So I'm gonna simplify and solve for X, so we can use cross multiplication. X times 5 equals X times 5 equals 8 times 12. So X is 8 times 12 over 5, which is 19.2 centimeter. The answer for X for this one. And how about this question? So we have triangle ABC and ADE. I believe that triangle ABC is similar to ADE, with this condition that we have angle A, which is common angle in the smaller and in the larger triangles, and we have angle C, which is congruent to angle E. So A is common angle, and angle C, let's call this C1, congruent to E, which is 90 degrees. So the condition is AA, and ABC is similar to ADE. Okay, and how about the corresponding size and their ratio? So as I said before, angle A is common. So let's start with the smallest triangle, and we have angle A. The opposite side is 2, and for the bigger one, the opposite side is 5. So 2 over 5 equals 2. And for C1, which is equal to E, the opposite side is AB, and we don't know the size of them, the lengths of them, so we can put it aside. So we have these two angles, angles B1 and angles D. Okay, and the opposite side of B1 is X, so X, And for D, the opposite side is this one, AE. So we have in fact x plus 3. And this is an equation and we should solve for x. So 2 over 5 equals x over 2x plus 3. 2x plus 3. I collect like term. Okay, and I'm gonna use cross multiplication. 5 times x equals 2 times 2x plus 3. 4x plus 6 and 5x minus x is 6 centimeter. In fact, AC is 6 and this side is 9. And we can check our answer. In fact, 2 over 5, which is the corresponding sides, is 6 from the smallest triangle over 6 plus 9 is 15. Okay, 5 times 6 is 30, 2 times 15 is 30. So we found that our answer is completely correct. And for the last question, we have this one. We have two triangles, ABC and MNP, and we are looking for the values of x and y. Okay. We have these two right-angled triangle, and we know that these two triangles are similar, and then we are going to find x and y. Okay, so the first thing that I'm gonna do is to write the corresponding ratio of angles of sides. So in fact we have 6 here over 3y, because this is the smallest side of this triangle and this is the smallest side of this triangle as well. So 6 is corresponded to 3y. So I'm gonna start from the small triangle to the biggest one. Okay, and we have 8, the medium size lengths, and over x plus 3. And then if I want to solve this, I have two unknown, x and y, and I'm not be able to solve this. So I should write the third proportion, the third ratio, which is AC, we don't know the value of that, over MP, which is 16. But I can find AC. Why? Because this is a right-angled triangle and I'm gonna use Pythagoras theorem, and AC is the hypotenuse of this triangle. So I'm gonna write this here. AC squared, which is the square of hypotenuse, equals the sum of the squared of two other sides, 6 squared plus 8 squared. So AC squared is 36 plus 64, which is 100, and AC is the square root of 100, which is 10 centimeter. Now I'm going to substitute 10 in this equation. So we can solve this one because the only unknown is x, and then use these two fractions to solve for y. Okay, so eight over x plus 3 equals 10 over 16. I'm gonna divide both by 2 to make it easier. So x plus 3 times 5 equals 8 times 8. So x plus 3 is 64 over 5, and x is 64 over 5 minus 3. So x is 9.8 centimeter. And how about y? So I'm gonna use this fraction and this one. 6 over 3y equals 10 over 16. So 8, 3y equals to 6 times 8 over 5. So y is 8 times 6 over 3 times 5. So 2, and y is 3.2 centimeter. So we found the values of x and y. And if we ask about the scale factor, the scale factor is, for example, 10 over 16, which is 5 over 8, or even 8 over 5. Both are correct. Okay, I hope you enjoyed this video. See you in the next one. Bye-bye.